Okay, so this is 2.3. I had to switch this up on the calendar. I didn't actually have 2.3 listed on there. I had a 2.3 quiz last week or something, some crap like that, so whatever. So this is 2.3 voltaic cells. This is the introduction to voltaic cells. So it says, obviously, in a spontaneous oxidation reduction reaction, electrons are transferred and energy is released. Well, that's good news. Let's see specifically how that works, though. So we get to voltaic cells, which are also called galvanic cells. You can use either term from what I understand. Maybe I'm wrong about that. Maybe there is like a for real difference, but I don't think there is. I know in the book that they kind of put them together as in voltaic and then in parentheses galvanic. We can use that energy to do work if we make the electrons flow through an external device, such as basically we're talking about a battery. Notice in the picture here you have like two electrodes. Those electrodes are, in this case here, probably copper is what it looks like, and this one is zinc. And those two are often used, and it creates a potential. In other words, the copper in the solution wants to give up some electrons. The zinc wants to accept some electrons. So that like when you have salt bridge, good Lord, I couldn't think of it. When you have the salt bridge connecting the two, where cations and anions can go back and forth in between, like this, then you have a situation where you've completed the circuit, and now you have the electrons flowing in like in a direction doing work. So when electrons move, we get electricity and energy. So let's keep going. So here's the diagram that you see in the book. I like this diagram because it keeps things pretty simple. Notice that there are some things about voltaic cells. Number one, we have electrons flowing through something, okay, like this. They're going in this direction. When we take a look to complete, like you can't see me, but I'm doing quotations in air. To complete the circuit, though, you need something that will exchange ions, and that something is the salt bridge, along with, of course, like another path for them to go outside the salt bridge. So here's what I'm trying to say. What I'm trying to say is that something's happening to the zinc here. So this is the zinc anode, and if it's an anode, it means oxidation. So the way I remember this is that they both have vowels. Anode oxidation happens there, and the electrons there, by the way, that's also negative. This is the negative part, I believe, and the electrons flow from negative to the positive. Now the cathode here is the positive part. So what's nice about this is, and I explained this before in problem 24 of the 20A problems, but what I'm talking about is that the cathode, that's the positive side, the anode is the negative side, and that works just like when we talk about how we have the cation for sodium chloride and we have the anion for sodium chloride. So sodium's the cation, sodium plus 1 is the cation, and chlorine minus 1 is the anion. Notice the plus and the minus go with cation and anion. The plus goes with cathode, and the negative goes with the anode. So I just want to make that like clear. So here's the situation. We got zinc is gathering electrons over here, and here's why. It's gathering electrons because the electrode is the zinc metal is going to zinc with a +2, which means that 2 electrons are then deposited like on the metal, and because zinc can transport electrons, the electrons kind of build up in this anode. When they build up in this anode and they get a release point which is like the wire out here, then this kind of forces the electrons to move along. When they move along, they come to the copper. Now when they get to the copper, here's what's going on in the copper. So the anode is actually like decreasing in mass because the actual zinc molecules are changing into zinc ions, which then dissolve in the solution, zinc nitrate. But over here, when the electrons are coming here with the cathode, so this ends up being the positive side. The reason why it's the positive side is because now we're getting the excuse me, now we're getting the copper plus 2 is gathering 2 electrons, and then we're getting copper metal. So the copper solution here with the plus 2 is now like forming the actual copper metal on the electrode, and that's how we're getting more and more. We're getting a buildup of copper metal on the electrode for the cathode, but we're losing zinc metal on the anode. Okay, I explained that as best I could. If you just want to know, like, and then if you're, now here's the cool thing, if you are building up copper on the cathode, then your copper nitrate, then the nitrate part, which is the negative part, the anion, is then flowing through the salt bridge and going to the other side like that, while over here we're like getting more, sorry, let me just get back to this. So we're getting more zinc with a plus 2, and the sodium nitrate that's in here, the sodium cations then are going back in the opposite direction. So nitrate's going to the left, sodium ions going to the right. So the cations go towards the cathode, and the anions go towards the anode. One of the reasons actually why it was named like that. So let's keep moving. So I talked a lot there, so a lot of the rest of this is just kind of like rehashing what I just talked about. So even once an electrode flows in the anode, blah, 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 blah. So anode to cathode, right, from minus to positive, the charges of each beaker would not be balanced if the flow of electrons would stop. So we keep going here. It says, therefore we use a salt bridge, usually a U-shaped tube that contains a salt solution to keep the charges balanced. So cations move towards the cathode, and the anions move towards the anode. Okay, I said all that. So for the voltaic cell, it says in the cell the electrons leave the anode and flow through the wire to the cathode. Okay, as the electrons leave the anode, the cations form dissolve into the solution. That would be the zinc plus going into, like the zinc going into the zinc plus here, like this. Dissolve into the solution in the anode compartment. The electrons reach the cathode. Cations in the cathode are attracted to the now negative cathode. Okay, now negative because the electrons are moving towards it here, which then attracts the Cu plus 2 cations. Obviously, they pick up 2 more electrons, and that changes this from a plus 2 to 0, which is what copper metal is, and then they deposit then on the electrode, on the cathode. So the electrons are taken by the cation, and the neutral metal is deposited on the cathode. Excuse me. Okay, hey, that's it. This is 20.4 right here. So because this is 20.4 and we talk about electromotive force, EMF, we don't need to get into that now. So thank you guys for watching.